Welcome to this particular presentations. As we have seen the various concepts of this hydrograph, the unit hydrograph, and as well as its applications, and some inference with reference to the peak discharge and the lag time, the base period, as well as the peak flow corresponding to 2, and summation or the superposition theorem, superposition technique, and S-curve techniques, and as well as the simple equation relating the catchment area, area of the unit hydrograph, and the depth, and flood hydrograph and the unit hydrograph. Coming to the numerical example on this particular one, let us take some numericals. Coming to the numerical example, so every example here we are going to focus mainly with reference to the one simple concept which I explained. The depth is equal to volume of the flow divided by catchment area, or area of the unit hydrograph or hydrograph divided by catchment area with the dimensional homogeneity principle here. The dimension on the left hand side must be equal to the dimension on the right hand side. That is the simple analysis of this particular unit hydrograph. And coming to the calculations of this particular the problem, every problem you keep it in your mind. In any competitive examination, first write the data, and related to the topic, whatever the list of formulas in your mind, put that formulas and choose this data which formula it will suit, and do these examples. Simple. In any competitive examination, a very simple technique how to crack the examination is always write the equation, write the data, list of formulas, which data suits for our problem, and solve it. Coming to this example on unit hydrograph, calculate a DRH direct runoff hydrograph due to storm was found to be triangular in shape, with a peak of 150 meter cube per second. The time from start of effective storm to a peak of 24 hours and total time base 72 hours. What is the duration of so the A bit greater than 72 hours, B bit 72 hours, C bit less than 24 hours, the D bit between 24 hours to 72 hours. So, coming to this example, we can see from this example, first the shape of the hydrograph, start from effective the rainfall, that is the effective storm, the duration, and also mention when the peak flow is going to occur and what is the base period. So, coming to these things here, first to draw the hydrograph. This hydrograph is a triangular shape here. This is the discharge. And this is the time, and a peak of 150. So, this is 150 meter cube per second, and coming to the effective storm to a peak of 24 hours. So, this is the time of peak, TPK. Is given as 24 hours, and the base period is 72 hours. This is the 72 hours. Now, we can compute from this particular example what is the duration of the storm. So, as far as this particular question is considered, it is a logical question, means with reference to the logical here, the duration of the storm which you mentioned here, the duration is with reference to two things. The one is, this is the river and this is the catchment, all this particular flow taking from the farthest point to the nearest point. When all the water accumulated and reached to the exit point and the water flowing in the river, the peak flow in the river will occur only once the recession, or we can say the stopping of the rainfall. That means once the rainfall stops, then the peak flow will occur. That means once the rainfall stops here, all this flow should reach here. That means the peak flow in the river can be seen only after the rainfall stops. That means the peak flow, that is which is occurred in the river, as per our hydrograph, the peak flow you are seeing in the river at 24th hour. At a time of 24 hours, the peak flow start, this is the start, this is the start. So, the effective storm to peak flow. So, here it is very clearly considered our rainfall duration and peak flow duration already when some time between 0 to 24 hours, at 24th hour peak you have seen. That means peak flow will occur only once the rainfall stopped already. That means the duration of the storm means somewhere less than 24 hours time, it may be 18th hour, 17th hour, 16th hour, 23rd hour, somewhere one particular time the flow rainfall intensity stopped. That means the rainfall stopped, then some more time this water takes to reach to the river. Therefore, based on this one, the duration of the storm is always less than the time of peak. The duration of the storm is always less than time of peak. So, this answer, according to this particular condition, the answer is C. The answer is C, less than 24 hours. Means sometime the rainfall has occurred between 0 to less than 24 hours time until that 23 hours, 22 hours, 21 hour, but the duration is taking place less than 24 hours, the rainfall has continuously occurred, then the flow reached into the river. At exactly 24th hour, the flow is peak. So, answer is less than 24 hours. Hope you understood this particular concept. The flow to reach to the river and peak flow, it takes some time. After stopping the rain, after some time we will see the maximum flow in the river. Coming to the second question. Coming to the second question, a triangular DRH, direct runoff hydrograph, due to storm has a time of base of 80 hours and peak flow (150 meter cube per second) occurring at 20 hour from the start. If the catchment area is 144 square kilometer, the rainfall excess in the storm was dash. So, here you are supposed to determine a triangular direct runoff hydrograph. It is the total. This hydrograph has the shape of base 80 and the peak flow 50. This is Q. This is 80 hours. So, this is 50 and occurring at 20th hour. So, this period is time 20 from the start. If the catchment area, the area represented by the basin catchment area is 144 square kilometer. Calculate the rainfall excess. That means what is the flow from this particular, the depth, the rainfall excess means that is nothing but the Q is 50 from this catchment. What is this depth? This depth of flow is nothing but the rainfall excess. So, coming to our equation, depth or rainfall excess is equal to A divided by A naught, that is area of hydrograph divided by catchment area. So, which is equal to area of the hydrograph half into, this is 50 is the ordinate, 50 meter cube per second, into the time is hours, here 80, into I am converting this, so this is 50 meter cube per second. So, this is seconds, this is hours. So, converting hours into seconds. Catchment area 144, this is square kilometers. Convert into meters, 10 power 6, you will get it meters. So, the answer is 5 centimeters. This you will get it into 5 into 10 power 2 minus 2 meter or 5 centimeters. So, now you can see the answer is 5 centimeter. The depth of flow here is, so water is moving over the catchment with a depth of 5 centimeters. So, this particular one, it is just calculated DRH. Suppose if we want to calculate the flow represented by same unit hydrograph, so 5 centimeters produce 50 from this particular one. So, here the answer is 5 centimeters over. Suppose if the same question also calculate the ordinate of unit hydrograph, means unit hydrograph means always the 1 centimeters. That means if the water is moving with 5 centimeter, the discharge flowing is 50. This is DRH. Suppose if we want the unit hydrograph ordinate from this particular one, the depth is 1 centimeter, what is the Q? So, it is very clear in the same question with the same data, what is the ordinate of unit hydrograph. Suppose if the same, one part is this one, if the same thing from the same catchment area, you want to calculate the ordinates of unit hydrograph. Unit hydrograph means refers to the 1 centimeter. So, for this problem answer is 5 centimeters. So, in the same question, what is the ordinate of unit hydrograph if we want? So, 5 centimeter produce a discharge of 50 meter cube per second. So, 1 centimeter produce how much? So, the answer is 1 into 50 divided by 5. So, answer is 10 meter cube per second. So, this is the difference between the unit hydrograph and the total the direct runoff hydrograph. So, this is how the another question also possible. Coming to the next question, for a catchment with an area of 360 square kilometer and the equilibrium discharge of S curve obtained by 4-hour unit hydrograph in meter cube per second. So, this is with reference to the S curve, that is the summation, and where the m is a fraction, that is from higher value the duration to the lower or lower to higher. In this particular one, m is fraction here, that is from the given value is higher, but to be developed is lower. Lower by higher, it will become the fraction. According to this particular technique, the equilibrium discharge formula as I mentioned, so Qs is equal to 2.772 into A by D, 778 into A by D. So, this is the formula, and 2.778, A should be in square kilometer, that is the most important, so 360. The duration should be in hours, here it is the 4. So, coming to this particular value, which is equal to 250 meter cube per second. So, now we can see with reference to this particular the values, that is the discharge here 250 meter cube per second is the equilibrium discharge, that is the highest maximum value which we have seen in our discussions. So, this is a direct question. Coming to the next question, it is on if the base period of 6 hours unit hydrograph of a basin is 84 hours, then 12-hour unit hydrograph derived from six-hour unit hydrograph is dash. So, the question is here, the unit hydrograph of a 6-hour, this one is given 6-hour unit hydrograph. This is the Q, this is the T, and this value is given as 84 hours. You are supposed to calculate the base period of the 12-hour unit hydrograph. So, this is the TB1, this is TB, the base period. So, this is the 12-hour unit hydrograph, this is 6-hour unit hydrograph, the N is equal to 12 by 6, which is equal to 2. The D is it is given to calculate from the given 6-hour unit hydrograph. D is equal to 6, the duration 6 hours, and the formula TB1, the unit hydrograph base period of 12 hour, is equal to TB plus n minus 1 into D. So, the given hydrograph, this is the given hydrograph, this is the required or developed hydrograph. So, in the data we have 6-hour unit hydrograph data, that is nothing but the discharge versus time we have. We are developing a 12-hour unit hydrograph. So, coming to this particular one, so the TB is given as 84 plus n is 2 minus 1 into D. So, this is, so this TB1 is nothing but 90 hours. So, the base period of the 12-hour, as I mentioned, as the base period increases, the discharge will be decreases. So, here the discharge is more and the discharge is less. Also we can say the if Q1 is the discharge of 6-hour unit hydrograph, what is the Q2? Same question here. If this is the answer for this one, if Q1 is the peak discharge of 6-hour unit hydrograph, so this value is Q1, this value is Q1, this is Q2. What is the peak discharge Q2? So, answer is less than Q1, greater than Q1, equal to Q1, and none of the above. So, the possible here, as I mentioned, as the discharge of this 6-hour unit hydrograph, Q1 is the peak discharge of 6-hour unit hydrograph. What is the peak of 12-hour unit hydrograph? That is Q2. If Q2 is the peak of 12-hour unit hydrograph. So, as I mentioned, the base period increases, the peak discharge will be decreases. So, this discharge is Q2, the relationship between Q2 and Q2 is less than Q1, therefore, answer is A. Answer is A. So, this is what the logic in this particular problem. Coming to the next question. Coming to the next question. A 2-hour storm hydrograph of a basin has 5 units of direct runoff the 2 hours unit hydrograph, the 2 hours unit hydrograph for this storm can be obtained can be obtained by dividing the ordinates of storm hydrograph by the A bit 5 by 2, the B 2 by 5, the C 2 and D 5. So, you can see here it is a simple concept, a storm hydrograph of 5 units of direct runoff. That means this is the storm or flood or total, means this is the depth with which a flow, let us say y, and when the depth of water is moving with y, the discharge 5 units of direct runoff. So, this is 5, and for this same storm a 2-hour unit hydrograph, this is the same storm hydrograph, 2-hour storm hydrograph, same unit hydrograph. Unit hydrograph means the depth is 1 centimeter. The depth is 1 centimeter. When with this depth water is flowing, what is the value of Q? Means what is this Q? That means here the storm of flood hydrograph means the base flow plus the ordinate of unit hydrograph. The discharge which you are going to get it, and accordingly the depth. This one includes the base flow plus the ordinate of unit hydrograph. So, the ordinate of unit hydrograph means a unit hydrograph means effective rainfall, that means after the subtraction of the base flow. That means, as I mentioned, if 5 centimeter produce 50, 1 centimeter produce how much? So, we got it here in a previous problem simply. So, this is if 5 centimeter produce 50, 1 centimeter produce how much? That is, I divided 50 by 5, that means here the answer is 5. You should see divide the ordinates. So, the divide the ordinates with this particular depth, that is divide the ordinates by this particular value. That means whatever you are going to get this particular value, the discharge should be division of the value, 50 by 5. So, division is by here 5, the answer is here. So, it should obtain divide the ordinates of storm hydrograph, answer is division by, it is mentioned here, dividing by what? Divided by 5. So, 5 centimeters produce this much, 1 centimeter produce how much? That is what the concept of here, the ordinates dividing by 5. So, answer is by dividing by 5. Coming to the next question. A 3-hour unit hydrograph U1 of a catchment area catchment area 235 square kilometers is in the form of a triangle with peak of 30 meter cube per second discharge. Full stop. Another 3-hour unit hydrograph U2 also in triangle shape of same base width as U1, but the peak flow is 90 per second. What is the catchment area? Of U2. So, see this particular question, the two unit hydrographs U1 and U2, one unit hydrograph, this is U1, another unit hydrograph U2, this is Q versus time, and this peak here is 30, this peak here is 90, and the both are 3 hours unit hydrograph. This is also 3 hour, this is also 3 hour, but the condition is given same base width. You can see here both are having same base width. So, TB and TB. So, both are having the same base width, and you have to calculate what is the catchment area A2 if this catchment area A1 is given as 235. The catchment area is in 235. Means the concept of this numerical example is based on one is U1, another one U2. Coming to this, both are unit hydrographs. Here also unit hydrograph, this is also unit hydrograph. Since both are unit hydrographs, so unit hydrograph, the definition, depth is equal to 1 centimeter. So, the depth is equal to this area of the U1 unit hydrograph divided by catchment area A1 is equal to area of U2 divided by A2, because here also the depth is 1 centimeter, here also the depth is 1 centimeter. So, both the cases the depth is same, here also depth 1, therefore, 1 is here also 1, here also 1. So, we can equate both the depths here, and accordingly the area of U1 half into the TB into peak discharge 30 divided by A1. So this is into 60 into 60 divided by A1. A1 is 235 square kilometers. So 235 into 10 power 6, which is equal to the denominator again second one, half into the area of this particular one, half into 90 into TB. Suppose if you observe this TB is in hours, here also in hours. So again you multiply with 60 into 60 divided with A2 into 10 power 6. So TB, TB, half, half. So calculating this particular value, the catchment area of the second one is equal to 705 into 10 power 6 meter square, or 705 kilometer square. Means we can see from this concept here, the answer is 705. So this catchment is 235 and the catchment area represented by next hydrograph is 705. So these are the simple examples on this particular the numerical examples. Any example you can solve it here. It is only one thing in this particular one. You have to first see the depth. The depth can be calculated based on the intensity of rainfall and the time. That is, you can also calculate the depth of rainfall. You can calculate from your rainfall runoff analysis. That means the losses also given. You can calculate knowing the precipitation and the loss, you can calculate the depth. So the rainfall and runoff analysis can be combined, so to get what is the depth of the rainfall. So this depth of the rainfall is given. For unit hydrograph it is always equal to 1 centimeter in our equations, basic equation which we considered, and now you can solve it with reference to this, any example on this one. Hope you understood this particular concept of the hydrology with reference to the surface hydrology parameters. And coming to the second one in the aspects of the concept of this particular hydrology. So that's all the end of this particular numerical examples. So let me illustrate the another concepts, that is on the reservoirs and the fixations and calculations of the capacities, and as well as the flood estimations and as well as the groundwater. So coming to the next topic in the surface hydrology. So go to the next topic on surface hydrology and reservoirs estimations, the capacity. Coming to the reservoirs estimations and capacity here. So we know now from this particular analysis, for a given river, for a given stream, we are able to estimate what is the value of Q from the hydrograph with the given information, and also based on the rainfall data and the runoff data, and we can modeling also can be possible here. So now that's all about these numerical examples. Let me illustrate the next new topic. So that's the end of this particular session, and so all the very best to my dear students. See you in the next class. Till then, keep preparing with Gradeup to score better.